Welcome, everyone. I'm excited to kick off today's presentation with a comprehensive guide to Azure Data Factory. In this session, we'll explore how to master data integration, automation, and workflow optimization in the cloud. Over the next few slides, we'll cover key concepts, best practices, and practical tips to help you make the most of this powerful tool. Let's get started. Welcome to the Introduction to Data Factory. In this section, we'll explore how Data Factory serves as a comprehensive tool for managing data workflows in the cloud. It's designed to make creating and overseeing these workflows much more straightforward and efficient. Think of it as your central hub for moving, transforming, and orchestrating data across different sources. One of the key strengths of Data Factory is its ability to support integration across a wide range of data sources, whether they're on-premises or in the cloud. This flexibility is crucial for organizations that handle large-scale data operations, as it allows them to scale and adapt without being limited by infrastructure boundaries. By automating data-driven workflows, Data Factory helps simplify complex pipeline management. This automation not only speeds up data integration processes, but also minimizes manual work, reducing the risk of errors and freeing up your team to focus on more strategic tasks. Overall, Data Factory is a cloud-based service that enables seamless data movement, transformation, and orchestration across various sources. It's a vital component for organizations aiming to streamline their data operations and leverage the full potential of their data assets. Let's take a closer look at the key components of Data Factory. First, we have data flows. These are visual interfaces that allow us to design and execute data transformations easily. They simplify complex data manipulation tasks, making it more accessible through a user-friendly interface. Next, we have linked services. Think of these as the connection information that enables secure access to external data sources. They ensure seamless integration with various data repositories, which is essential for a smooth data pipeline. Moving on, datasets define the structure of the data we want to process. They act as templates for data inputs and outputs, helping us understand and manage the data in our pipelines. Activities are the individual steps within a pipeline. Each activity performs a specific task, whether it's moving data, transforming it, or controlling the workflow. They are the building blocks of our data processes. Finally, pipelines are logical groupings of activities. They orchestrate the entire workflow, organizing and executing data processing tasks in a coordinated manner. Together, these components form the backbone of Azure Data Factory, enabling us to build efficient, scalable data solutions. Let's take a closer look at some key benefits of using Azure Data Factory. First, it provides a competitive advantage by enabling organizations to anticipate market trends and customer needs with greater agility. This means you can stay ahead in a constantly changing market environment, which is crucial for maintaining a competitive edge. Next, we see operational efficiency, where Data Factory helps streamline ETL workflows, reduce data duplication, and improve overall data quality. These improvements lead to significant cost savings and allow your team to focus on more strategic activities rather than manual data management. Finally, better decision-making is a major benefit. With accurate, data-driven insights, organizations can make informed choices that enhance customer acquisition and support growth. When you combine these benefits, it's clear how Data Factory can transform your data operations to be more proactive, efficient, and impactful. Let's now move on to the prerequisites and setup required before we start working with Azure Data Factory. First, you need to ensure you have an active Azure subscription. This is essential because it allows you to create and manage your Data Factory instance seamlessly. Without it, you won't be able to set up or run any data pipelines. Next, you'll need an existing Azure Synapse Analytics workspace that includes Data Lake Storage Gen2. This workspace acts as the backbone for your data integration and analytics tasks. It's where you'll store and process your data, so having this ready will streamline your workflow. You also need to prepare a storage account that contains sample data containers. These containers will serve as the data sources and destinations during your processing and transformation activities. Setting this up ahead of time helps ensure your pipelines have the right data to work with. It's crucial to verify that you have the appropriate user permissions, such as being a subscription owner, administrator, or having the Data Factory contributor role. These permissions are necessary because they grant you the access needed to configure and manage your Data Factory environment properly. Finally, you'll set up your Data Factory instance itself. This involves selecting your Azure subscription, choosing the right resource group, picking a region close to your data sources, and giving your factory a name. Using version v2 is recommended for the latest features. You'll complete the setup by configuring Git integration for version control, and then launching the Azure Data Factory Studio, where you'll do all your data pipeline development. Getting these prerequisites right sets a solid foundation for a smooth and efficient data integration journey. On this slide, we're taking a closer look at the Data Factory user interface, which is essential for streamlining your data workflows. The interface allows for rapid prototyping and quick insights generation, helping you move from idea to implementation faster. This means you can test and refine your data processes more efficiently. The design elements are intuitive, making it easy to build and visualize complex data pipelines without needing to write code. This simplification really helps in managing sophisticated workflows with ease. One of the key features is the drag-and-drop functionality. The Azure Data Factory Studio provides a no-code interface, so even users with minimal coding experience can create and modify pipelines. This empowers analysts and developers alike to focus on what really matters, integrating and transforming data, without getting bogged down by technical hurdles. Overall, this user-friendly interface is central to making data integration more accessible and productive, supporting the broader goal of efficient data management in the cloud. Now, let's take a look at how Data Factory connects to various data sources. First, we have linked services, which leverage Azure Private Link, private IPs, and Azure Key Vault integration. These features are crucial because they help protect your credentials and ensure compliance with security standards, giving you peace of mind when managing sensitive data. Moving on, Data Factory supports a wide range of other data sources, including REST APIs, ODBC, OLADB, and MongoDB. This variety ensures you have the flexibility to connect to many different systems, whether they are cloud-based or on-premises. Speaking of cloud, Data Factory seamlessly connects to SaaS platforms like Salesforce, Dynamics 365, and ServiceNow. It also supports Zendesk and Adobe Analytics, making it easier to integrate various SaaS solutions into your data workflows. In addition to SaaS, there's robust support for cloud storage options such as Azure Blob Storage, Azure Data Lake Storage, and Azure SQL Database. Furthermore, it extends compatibility to Amazon S3 and Google Cloud Storage, giving you a broad spectrum of cloud data sources. Finally, Data Factory isn't limited to cloud or SaaS. It also connects to on-premises data sources like SQL Server, Oracle, Teradata, MySQL, and PostgreSQL. It even handles local files and network shares, providing a seamless bridge between your on-premises environment and the cloud. Together, these features highlight how versatile and comprehensive Data Factory is when it comes to connecting to all kinds of data sources, whether cloud, SaaS, or on-premises, supporting your entire data integration journey. Now, let's dive into building pipelines and activities, which is a crucial part of our comprehensive guide to Azure Data Factory. First, selecting the right storage solutions is key. You want to choose options that fit your specific data needs, whether that's speed, cost, or scalability. Next, designing your database schemas carefully is essential for ensuring that data is organized efficiently and can be retrieved quickly when needed. Once your storage and schemas are in place, the next step is setting up pipeline orchestration. This involves scheduling your data flows and clearly defining dependencies so everything runs smoothly and in the correct order. Handling failures effectively is also critical. By setting up proper error handling mechanisms, you can ensure your data processing continues seamlessly, even when issues arise. When your pipelines are ready, deploying them to production requires robust monitoring systems. This helps you keep an eye on performance and quickly catch any problems. And of course, establishing regular maintenance routines is vital for long-term reliability. Lastly, planning the data consumption layer thoughtfully ensures that your processed data can be utilized efficiently. It needs to support diverse access and analysis requirements, making it easier for your team to leverage the insights they need. All these steps, storage, schema design, orchestration, deployment, and consumption planning, are interconnected and vital for building a resilient, scalable data pipeline that supports your overall data strategy. Let's talk about automation with triggers in Azure Data Factory. This feature helps reduce the need for manual intervention during pipeline execution, which means less time spent on repetitive tasks and fewer chances for errors. As a result, it significantly boosts overall productivity and makes operations much more streamlined. Now, focusing on workflow efficiency, Azure Data Factory processes data within fixed, non-overlapping time windows. This approach is particularly perfect for handling time series data systematically and efficiently, ensuring that data is processed in an orderly fashion. Moving on to the different types of triggers, first, we have the tumbling window trigger. This trigger initiates pipelines based on specific events, such as changes in Azure Blob storage. This makes it ideal for real-time data ingestion and processing, enabling dynamic workflows that respond promptly to new data. Next, we have the event-based trigger. This trigger runs pipelines at regular intervals, which is great for automating routine ETL jobs. It helps ensure consistency in data processing and minimizes delays caused by manual scheduling. Finally, there's the schedule trigger, which allows us to set up pipelines to run at predefined times, creating a reliable schedule for regular data workflows. All these triggers work together to make Azure Data Factory a powerful tool for automating and optimizing your data workflows, aligning perfectly with our goal of creating efficient, automated data pipelines. Let's take a closer look at some of the advanced features of Azure Data Factory that really enhance its capabilities. First, we have the metadata-driven pipelines. These enable us to adapt workflows dynamically based on the data source changes, which means improved efficiency and less manual intervention. It's about making our data pipelines smarter and more responsive. Next, there's the AI-powered assistant called Copilot. This tool can actually build and manage pipelines just from natural language inputs. Imagine telling it what you need, and it handles the setup and troubleshooting for you, streamlining the entire process. Finally, we have Dataflow Gen2, which provides a low-code interface with over 30 data and AI-based transformations. It simplifies complex ETL tasks, making data processing more accessible and efficient. All these features tie back to our overall goal, making data integration more agile, scalable, governed, and cost-effective. They're designed to help us work smarter, adapt quickly, and deliver better insights faster. Now, let's look at how integration with OneLake enhances our data capabilities. By connecting with OneLake, we create a unified data environment that simplifies access and management. Moving on to analytical insights and reporting, this integration empowers us to deliver actionable insights through Power BI, which is crucial for strategic planning. When decision-makers have real-time, relevant data, they can make smarter choices faster. Next, we see the importance of a unified governance and compliance framework. This ensures that our data is managed securely and in accordance with regulations, which is vital for maintaining trust and legal compliance. In terms of data science and machine learning, OneLake supports end-to-end project workflows, from acquiring the data to training models, making it easier to develop accurate, robust solutions. Finally, consolidating data into OneLake allows for quick insights, enabling businesses to respond promptly to changing conditions. And by facilitating efficient ingestion, transformation, and loading from diverse sources, it ensures seamless data flow and accessibility across the organization. Altogether, these features highlight how OneLake integration strengthens our ability to derive value from data, supporting smarter, faster decisions throughout the enterprise. Let's talk about troubleshooting and debugging in Azure Data Factory. First, you can test activities without running the entire pipeline. This is really useful because it allows you to isolate specific parts and make sure they're working correctly before executing the full process. It helps save time and makes debugging more manageable. Next, when you enable debug mode testing, you gain access to detailed logs and dependency analysis. This information is crucial because it helps you understand exactly how your pipeline is behaving and pinpoints where issues might be occurring. Think of it as having a magnifying glass to examine every step. The Monitor tab is also an important tool for debugging. It provides a centralized view where you can monitor your pipeline's execution, see logs, and identify any problems. It's like having a control tower guiding you through the debugging process. Implementing business logic, such as try-catch blocks, is essential for catching and resolving errors gracefully. These blocks let you isolate specific error scenarios so you can handle them without disrupting the entire pipeline. It's about making your workflows more resilient. Additionally, you can use allow pipelines to continue despite non-critical failures, what we often call best effort steps. This approach ensures that minor issues don't stop your entire process. Instead, your pipeline can skip over non-critical failures and continue executing. Finally, for managing errors more systematically, there are error handling activities. Using upon failure paths, you can manage errors gracefully, ensuring that issues are addressed without causing a complete halt. This structured approach to error handling is key to maintaining robust and reliable data workflows. In summary, these debugging and troubleshooting tools help you build more reliable pipelines, quickly identify issues, and keep your data processes running smoothly. Now, let's talk about how we can optimize our Azure Data Factory pipelines through best practices. First, leveraging Azure Monitor is essential. It helps us identify bottlenecks and allows us to continuously improve performance. Effective monitoring is the key to maintaining high pipeline efficiency, ensuring everything runs smoothly. Next, using Azure integration runtimes is crucial for handling workload growth. Scalability ensures that our pipelines can adapt seamlessly as demands increase, preventing any performance issues down the line. Additionally, running multiple activities simultaneously can significantly optimize resource utilization. This parallel execution reduces processing time and boosts overall efficiency, making our workflows more robust. We also want to make our pipelines dynamic and easier to maintain. Parameterization plays a big role here. It simplifies updates, promotes consistency, and makes our pipelines more flexible to changing requirements. Finally, breaking workflows into reusable components, or modular design, enhances both performance and adaptability. It allows us to build more flexible and manageable solutions, which is vital as our data processes grow more complex. All these practices, when combined, help us create efficient, scalable, and maintainable data workflows, aligning perfectly with our goal of optimizing Azure Data Factory. Let's talk about security in Data Factory, which is a crucial part of our comprehensive Azure Data Factory guide. First, adhering to standards like GDPR and HIPAA is essential to protect sensitive data and avoid potential penalties. It's about making sure we're compliant with legal requirements to safeguard both the data and our organization. Next, security monitoring is vital. By enabling real-time logging and anomaly detection, we can continuously keep an eye on our systems. This helps us quickly identify and respond to any threats or unusual activity, maintaining the integrity of our data environment. Data masking is another key point. We need to safeguard sensitive information while still keeping the data functional for testing and analysis purposes. Proper data masking ensures that confidential data isn't exposed unnecessarily, balancing security with usability. When it comes to access control, Implementing strong authentication methods, like two-factor authentication and role-based access control, is critical. This restricts access to only those who are authorized, reducing the risk of internal or external breaches. Finally, protecting data both in transit and at rest is fundamental. Using robust encryption protocols ensures that our information remains secure whether it's being transferred or stored. Encryption is the backbone of data security, and it's something we must prioritize to keep our data safe across all stages. Now, let's look at some of the key learning resources and career paths related to Azure Data Factory. As you explore this area, you'll find that the core concepts revolve around data warehousing, migration, and real-time streaming. These are fundamental skills that enable you to handle large volumes of data efficiently and in a timely manner. Beyond these, there are other exciting areas such as IoT integration, big data processing, and hybrid cloud solutions. These expand your ability to work across different technologies and architectures, making you more versatile in the data landscape. When it comes to potential roles, think about positions like data engineer, data architect, and data pipeline engineer. These roles focus on designing, building, and managing data workflows and infrastructure. There are also specialized roles like data warehouse engineer, ETL developer, and machine learning engineer, which are equally important in leveraging data for various business needs. To grow your expertise, I recommend diving into official Microsoft documentation, enrolling in online courses, and engaging with community forums. These resources help deepen your understanding and keep you updated on the latest developments. Additionally, hands-on workshops and digital learning platforms are invaluable for gaining practical experience. They allow you to apply what you've learned in real-world scenarios, which is essential for mastering Azure Data Factory and advancing your career in data management. Now that we've covered the essentials, let's talk about how to get started with Azure Data Factory and keep growing your skills. On this final slide, I want to emphasize the importance of exploring advanced features. This is how you deepen your understanding and really leverage the full power of Data Factory. Using the resources available, whether tutorials, documentation, or community forums, will help you continuously improve. Think of learning as an ongoing journey. The more you experiment and explore, the more confident and efficient you'll become. Mastering Data Factory isn't just about knowing the basics. It's about applying what you learn to boost your productivity. By building pipelines and exploring features like Dataflow Gen2 and Copilot, you can streamline your data workflows and make smarter decisions faster. Remember, start by building simple pipelines with core activities like copy and lookup. Automate your workflows with triggers to save time and reduce errors. And don't forget to set up your Data Factory instance properly, with the right permissions and connections to diverse data sources through linked services. So the key takeaway is this: keep practicing, keep learning, and use every resource at your disposal. That's how you'll truly master Data Factory and unlock its full potential for your data projects.